I want to talk to you about a problem that is that I think we all have, but I think I have this problem a little more than you. Why? So Xavier and Corail, and I'm leading the GitHub Security Lab, and our mission is to help secure open source software. The problem that I want to talk to you about is the relative scarcity of security expertise in software development. Right? Some studies suggest that there is only one security professional to 100 developers. So let's imagine that in this room, if we're lucky, well, only this lady here knows how to actually write secure code. We are all software developers. Every day we are shipping code that is crucial for our daily lives, right? But only her can actually write secure code, if we're lucky. And why did I say that I feel this problem a bit more than you? It's because I'm trying to secure open source. And in open source, the situation is even worse, right? We don't have the same funding as we have in enterprises. So how do we address this problem? Well, what I'm trying to do is first amplify the scarce security knowledge, right? Trying to make one security researcher's work worth, more developers, right? I want this research, this work, to be impactful for more developers. This is the first thing, the first axis. The second thing is to empower developers. I don't want to transform all developers into security experts, right? It won't work. But basically, the idea is to try to make them autonomous to take the right decisions and trying to basically get them a bit more towards where we want them to be. And I think that if we don't do these two things, amplify and empower, it won't work, right? It won't solve our problem of solving this scarcity of security knowledge in our industry. So this is basically what we're doing in the GitHub Security Lab. We are trying to take security knowledge from the community, amplify it, and put it at the fingertips of the developers. So this talk is called Human versus AI. So I will show you what, in the first part, I will show you how we are doing this as humans, and then in the second part, how AI can help for the same problem. So bear with me, because the first part of this talk will be, boring humans. I'm sorry. And then we will eventually get to talk about AI. So I will show you 3 examples of what we are doing as humans to solve this problem, to amplify and empower, to amplify security research and empower developers. So first, education. At the Security Lab, we are doing office hours, we are giving support, we are giving training, workshops, educational articles. We are doing all of that for free. And about security tooling, about security best practices, about security research techniques, etc., vulnerable code patterns, etc. We are doing all of this for the audience of security researchers and developers. For example, we released recently training called the Secure Code Game, which is basically, I will show you what it is. It's you start with a repository on GitHub. When you click on Start Course, it will fork a repo on your account, and from there you can, code into your preferred editor, or you can open a code space on it to code in the cloud. And basically what you will have to do, you will have a certain number of levels, and you will have to look at code and try the vulnerable pattern in that code and fix it, And to help you, we have also an exploit that you can launch, right? And of course it will fail, the test will fail, and you will need, as a game, to make this test pass by fixing the vulnerable pattern, right? Why am I showing you this? Because it's yet another training, right? But this one exemplifies the principles that we are following. First, amplify, because this is open source, so it gets contribution from the community. It gets pull requests from the community to add more levels or to add more exercises. And two, because we tried to really mimic what a developer is doing, right? Play the game just by reading code, hacking code, running tests, refactoring, etc. Right? So this is just an example of how we can follow these principles of amplify and empower to do this training on secure code patterns. The second thing that we're doing is variant analysis. Variant analysis is the process of using one security vulnerability to try to find more instances of this pattern in code. So we are doing that for open source code, but you can do that for all the code that you want. And we are doing that with CodeQL. CodeQL is GitHub's SAST engine, and it's a tool that we use to find insecure pattern in your code. Basically what it does is that what you see on the left-hand side, it's static analysis of your code that will extract all aspects of your code, the abstract syntax tree and other semantic information, into a relational database. And then, once you have this database, then you can run queries on it to explore your code, as if you were running a SQL query. But on top of this, we offer a DSL, a language, an object-oriented language, right, that abstracts the SQL for you. So for example, here you can ask to find all functions called my function, right? So basically, we map the table called function with a class function, right? And the column name of this table is mapped with an accessor of this class. And for the example here, you can see that you can join two tables. So instead of joining like you would do in SQL, you do the join with this line here, c.target. So the target of the call is this function, and it will abstract the join for you and make everything work. So what it's doing is that it gives you this high-level, super expressive language, which transforms this SQL query into English, right, that you can basically read. And this is something that we use to explore our code and to find security vulnerabilities. Because it's an object-oriented language, one of the benefits is that you can build on classes, libraries that we, GitHub, build, but also that the community builds. So you really take advantage of the community's security expertise to build on that. For example, we have a native taint tracking library. This library will tell you if untrusted data, right, can flow to a dangerous place. So, for example, here, we can see that this name here flows to name, that it flows through this external library, right? We don't even know that, but we can specify that this propagates my tainted data to this sink here, which is the argument of context.lookup. So here, this is an example of a JNDI lookup that uses an arbitrary string. So I guess it rings a bell for some of you, for our security expert, perhaps. This is basically log4shell, right? And what I will do now is that I will show you an example of log4shell query. Okay, let me just continue that. So this is the boilerplate of this native taint tracking library. If I want to find the log4shell vulnerability, let's remember the exploit. An attacker can control the parameter passed to logger.info, and this arbitrary string will end up into context.lookup, a call to context.lookup, right? So I have this boilerplate code coming from my taint tracking library, and what I have to do is just to implement these two functions here, isSource and isSync, right? My source is the parameter of type string of logger.info, and my sync is the first argument of a call to context.lookup. And this is what I have to define. So if I look at what my query is, this is the definition of my source. I define that my source overrides a method from this package, this type, this method. And it has one parameter, and this parameter is of type car sequence. And so this will be my source. And how do I declare my sink? I can declare my sink as being the first argument to a call to the call of lookup. But remember that, well, this is an example of the benefit of having this object-oriented language. It happens that one user from the community created a class called JNDI injection sink, which describes JNDI injection sinks. And so I can build on that. I don't need to reinvent the wheel. I can build on that to use this query to run, to do my search, to do my exploration of the code. I will run the query for you so that we can see if we find log4shell. So the database that I'm using here, the code base that I'm using here is the vulnerable version of log4j, obviously, because it's fixed. So what Corail is doing here is that it's taking the definition of my source, it's taking the definition of my sinks, and it will search for all the possible paths in my code execution, right, that matches, that can basically match a flow from one of these source to one of these sink. And it finds 4 paths here. Let's have a look at one of these paths. You can see that it goes from this parameter of logger.info, right? And it goes through a certain number of steps through several files, several functions, a lot of them, right? I'm scrolling down. 116 steps to go down to the argument of context.lookup in JNDI manager.java. So this is something that obviously you couldn't do as, by just reading code or following the code, but Corail can do it for you by doing this taint tracking through all of these steps. If we look at the other path here, you can see that this one has 150 steps through different functions of the code to tell you that, yes, you have a risk here of having this untrusted data flowing to your JNDI lookup. And so that's the demo of Corail. Let's go back to the slides. And what I want you to remember is that this is a fantastic way to amplify the knowledge of one security researcher into hundreds, of variants of our security vulnerabilities. So, for example, my colleague Alvaro, he was doing, some variant analysis with this same query that we saw. He was kind of broadening the sources and the things, and he found another variant of the same pattern, which was called by InfoSec Twitter text4shell, right? But it was much less scary than log4shell, but it was a code injection, a code execution in Apache common text with a similar pattern. So this is really an example of, hey, I've got this security vulnerability, I'm coding the pattern into a Corail query, and it allows me really to amplify this, this research into actionable code exploration for others. And, well, you can see examples of that work if you look at our Corail trophy case here. You can see a lot of security vulnerabilities and CVEs that we find just by doing that, just by doing this variant analysis on existing security knowledge, amplifying it via Corail, and finding more of these security vulnerabilities. And once these queries are written, they are executable code that that developers can run into their CI. So it's really putting this security research at the fingertips of the developers, because they can see these alerts directly in their pull request, as if it was just another comment from their security expert directly in their pull request, directly in their toolings, without changing their workflows, without going to another place, right? And so this is really how we empower developers, right, to be autonomous and to take the good security decisions. And empowering people mean that they also get knowledge in the process. So here they can click on more details and see explanations about the vulnerability, but this is knowledge that they get applied to their cases, applied to their code, so it's really knowledge that would stick. Finally, we are also curating security advisories. So we maintain this security advisory database, the GitHub security advisory database. I think that all of us can relate to how tedious it is to get security vulnerability information from various feeds, aggregating them, enriching the information, etc. We have a team of security analysts that does this curating of information, and this is the data that goes directly into developer toolings like our own SCA, Dependabot, that will generate pull requests for developers automatically to update. And it also goes to developer tools like NuGet Audit or NPM Audit, for example. So again, an example of how we amplify security information that goes directly into the developer's workflow. And this is an example that I love, is that how do we amplify this knowledge? Well, this database is free and open source. So again, you have here an example of an advisory that was misleading consumers because they could think that they were safe if they were not in a specific context. It was wrong, right? They were unsafe. And so a community contributor was able to create a pull request, add this information to make the advisory more accurate. And this information got, again, at the fingertips of the developers because it was into Dependabot alerts, it was into tools like NPM Audit, etc. So another example of amplifying information and putting it directly into the developer's workflow. And of course, if we think about Log4Shell, for example, minutes after Log4Shell was disclosed, our advisory was published, and 375,000 alerts were sent by Dependabot to open source projects. And after 7 days, 48% of these active projects that were alerted by Dependabot upgraded to a fixed version, so in just a week. So that's again an example of getting security information, really making it impactful for the developers. Okay, now I showed you 3 examples of how we humans, we are trying to do these 2 things, amplify and empower. Now, let's see how AI can help us do that, right? So for that, I will do a demo of GitHub Copilot. So I will try to rely on the Wi-Fi, okay? If that doesn't work, I will have to move to videos, pre-recorded videos. But let's try first with to see if the Wi-Fi is with us. Okay, so no. So here I prepared for you some code that I wrote. So this is a simple web server with only one root, right? And so if you, as a parameter of this root, you put a username, then it will create a SQL query to the backend database and retrieve the profile of this user. So it's code that I wrote myself, and so I would like someone in the room to tell me what is wrong with this code. So not you, because you're our secure code expert, but someone else in the room, please. Yes?
SQL injection?
Yes, there is a SQL injection. Does our secure code expert agree?
It's like SQL injection?
Yes, thank you. Okay, it's validated by our secure code expert. So yeah, indeed, well, You all know if I close my query here and add more query like drop table, then I will get a SQL injection here. So, so first of all, this is code that I've written myself, right? But if, for example, I asked Copilot to write it for me, and look at that. Copilot uses a parameterized query instead of concatenating the search with the rest of the query. So there is no more SQL injection here, right?
That's pretty wild.
Yeah. So, so if I let Copilot create this code for me, it will do that. So now, disclaimer, right? You must never blindly accept any suggestion, right? Copilot is an AI pair programmer. Copilot is not a secure code expert, right? Remember that GitHub Copilot is your co-pilot, right? You are still the pilot. And when Copilot was out, there was this research from researchers of New York University saying that Copilot was generating as much vulnerable code as a junior developer would, right? And it was not a surprise because Copilot is trained on public code that contains vulnerable patterns, and so of course it can synthesize suggestions that contain these vulnerable patterns. But since then, and they continue to do it, the Copilot team is working very hard at teaching the model what is vulnerable code, what is not vulnerable code. We also released an AI-based vulnerability filter that can filter out, the common mistakes that people can do, like SQL injection, for example. So yeah, so first for the coding use case, you can see that it can already be a nice help. But I would like to get back to my code. Because again, what I prefer is that, so I'm the pilot, right? So I'm doing this, and I would like to use Copilot as my peer programmer. So I will ask Copilot to do a peer review of that code. So for that, I will use the Copilot chat feature. It's not generally available. You can go be on the wait list, but I will just use it to show you how AI can help us achieve the same goal of amplifying security research and empowering developers. So I want to do a peer review, right? And I will ask for a colleague a peer review. When I do that as a developer, I know what is my context, and I know what is my weakness, right? So I know that it is a web server that will go outside, and I know that security is not my forte. So I will basically ask my peer reviewer to tell me if there is any security issue here, right? So let's ask Copilot if there is any security issues in that code. And boom. Okay, so the code you provided does not contain any obvious security issues. However, it is important to know that the code is vulnerable to SQL injection attacks. Well, okay, so Copilot is a bit contradicting itself, right, here? But, well, Copilot found that it's vulnerable to SQL injection attacks. And to prevent this, you should use parameterized queries instead of concatenating strings to build SQL queries. Nice, right? But, well, accurate, almost, but still not very helpful, right? Not very actionable for a developer, right? I mean, perhaps I don't even know what is an SQL injection, and I don't know what is parameterized queries. So what should I ask Copilot?
Identify.
Sorry?
Identify.
Can you speak louder?
Identify.
Identify? Just, how do I?
Can you identify the vulnerability?
Okay. Can you identify the vulnerability in my code, right?
Yeah.
Yes, the vulnerability in your code is that it is susceptible to SQL injection attacks. Specifically, the search parameter. Search parameter is concatenated directly into the SQL query string, which means that an attacker could potentially inject malicious SQL code into the query, and then to prevent this, blah, blah, blah. Okay, I still don't know what is a SQL injection. Perhaps we can ask what is a SQL injection? Okay, that's what is a SQL injection? Okay, not super helpful, right? A SQL injection is a type of security vulnerability that occurs when an attacker is able to inject malicious SQL code into a database query. Can we ask for examples? Or can you give me concrete, examples relevant to my code? I really want to understand what's happening with my code. I thought it was good. Okay. Sure. Here's an example of how an attacker could exploit the SQL injection vulnerability in your code. Let's say that the search parameter is set to the value admin. The SQL query that is constructed by your code would look like this. Okay. Now, an attacker could exploit the vulnerability by setting the search parameter to the following value. Yeah, we are closing here the first part, and we are adding or1 equals 1. And this would result into the following SQL query. It tells me that the the character indicates a command, so everything after that will be ignored. And of course, what it will do is that the query would return all rows from the users table, effectively bypassing any authentication or authorizations. Nice, right? Okay. So now, yeah? How can I fix it? And look, how can I use parameters queries in my code to prevent SQL injection attacks? Okay, let's click on that. And then, so it tells me, okay, use parameterized query. So here's an example of how you can modify your code. Okay, and interesting, I love that part, right? Because I didn't know about parameterized query before. It explains to me, hey, this placeholder is used to represent the value, and then the value will be passed to the query, and then it will ensure that the value is properly escaped and prevents SQL injection attacks. So I'm learning in the process. Cool. So what I need to do, is to take all this code, and here I'm saying, okay, please replace my code with your suggestion, and here we go. My code is safe now. So that's a use case for the coding activity, right? But as developers, when we don't only code, right? We also test. And for testing security, what I'm using myself is I'm using CodeQL, right? To test, to write these queries that test, for example, that my code now doesn't have any SQL injection. And one funny thing happened, I was giving a talk at the CNCF conference in Seattle in February, and I was doing a demo of CodeQL, and I was demoing the log4shell query that I showed you, but I was coding it live. And I forgot to disable Copilot. And so during my demo, I started writing the query, and boom, Copilot basically wrote it for me. So the CodeQL demo basically switched to a Copilot demo at the end. That was not intended, but that was fun. So basically, I was there writing my query, and then Copilot was, I started typing the query here in CodeQL and this is quite useful because, it's a new language that your security researchers don't know about, right? And so having Copilot being helpful, it's working here, right? Helping you learn this new language and being productive in writing these CodeQL queries is very, very helpful. Okay, I think the Wi-Fi is failing me now, so yeah, you will have to trust me on this or to look at the video of the CNCF conference. But yeah, let's go back to our slides. So what did I show you? So I basically wanted to show you how AI could be useful for all the phases of the development cycle. So we saw example how GitHub Copilot could help us code, could help us do the code review, could help us learn about security patterns in the process, and could help us test, right? And we are with AI, we are looping into this cycle much faster than we do usually. So as a conclusion, I would say that for this use case of trying to amplify community knowledge and to empower developers, AI is a very good match for this particular use case, right? And why is that? Because I think that you still have the human who has the knowledge, who has the expertise, right? But AI has speed and scale. Speed, the time to get this knowledge to the developer's keyboard, it's just impressive. And the scale at which we can deploy this knowledge to developers is also unbeatable. So thank you. I think we'll have time for some questions.
Sure. Thank you. Thank you for the talk. Are all these tools available for the basic GitHub, or are they specific for enterprise customers, or are they pretty much available to the whole GitHub on the basic, subscription, or is it some of them are specific to enterprise?
Yeah, no. So Copilot, you have an offer, even for open source and individuals, and you have an offer for business, which will be used for with GitHub Enterprise, indeed. Does that answer? Yeah.
So they're available for both?
Yes, you have a Copilot for individual that you can use. Yes. Yeah.
So it's a freemium business model, right?
Sorry, sir, do you want to?
So it is a freemium business model. Do you have a free version and then more involved complete packages for enterprise, and that's
for Copilot specifically. For Copilot, it's you don't have a free version of Copilot. Okay. It's free for education. It's free for teachers. It's free for also for some big open source projects maintainers, right? But otherwise, no, it's paying. However, the security tools like Corail, for example, it's free for open source. All the GitHub security tools are free for open source and paying for enterprises.
Could you elaborate again how the Copilot team is preventing potentially malicious code? Is there a threat where hackers are creating more and more repos to manipulate the Copilot output?
Yeah. So I think there are two things going on. The first one is that it naturally improves, by learning what is vulnerable, what is not vulnerable. There is this, but the team developed also a filter, on top of the model. There is another, still AI-based filter that knows how to detect some specific vulnerable patterns and block them from suggestions. It kind of works as the same as the filter for offensive language, for example. It's kind of on top of these suggestions. It filters out these suggestions.
Is there a white paper on that filter?
I don't know. There is a blog post about this vulnerability filter when it went out, but nothing as detailed as a white paper. I'm not sure.
Oh, what a great talk, everyone. Thank you so much. Let's give her another round of applause for Rene.
Thank you.